Good afternoon and welcome to Leveraging 3D Printing to Build a Resilient Supply Chain. Special webinar exploring the potential for 3D printing in a post-COVID world. My name is Bob Treblecock. I'm the Editorial Director of Supply Chain Management Review, and I'll be the moderator for today's webinar. Now, joining me today are two experts in the area of 3D printing. Avi Reichental is the founder of Nexa3D. They deliver fastest industrial-grade stereolithography DD printers for engineers and manufacturers of all business sizes. And Chris Lydiard is the market segment head for automotive and industrial parts technologies for the Henkel Corporation, a market leader in adhesive technologies, sealants, and functional coatings. So to today's webinar. Warren Buffett once said that only when the tide goes out do you discover who's been swimming naked. When it comes to gaps in the supply chain, we've all learned a lot during COVID-19 about what's been covered up and what's not. Hey, maybe a little too much. I think there's a general consensus that the current crisis is going to enhance and accelerate the adoption of new technologies, including perhaps 3D printing. So what have we learned? How do we plan or adjust for the next crisis? And what role might 3D printing play going forward? That's what Chris and Avi are going to discuss over the next 30 minutes. And after that, we'll save time for a question and answer period. If you have any questions for either, just submit them on the screen and we'll pose some of them when the time is right. So let's get on with it. Chris, Avi, welcome. And let's start by, why don't both of you tell us a little bit about yourselves and your backgrounds?
Chris?
So, Chris Lydiard here. I'm currently living in sunny Michigan. Obviously not a US citizen by birthright, but been in the US for some time, mainly in the automotive industry, in the parts business. So injection molding, actually ran the plant for a short amount of time. So know a lot about injection molding. Actually brought the first 3D printers into Henkel from a prototype perspective. So excited to have this discussion with Avi and answer your questions going forward.
And Avi, how about you?
Yeah, I'm Avi Reichental, also not a US by birthright, but a citizen nonetheless by choice. A pioneer in 3D printing, a venture capitalist, and an inventor, a person that is passionate about paying it forward and transforming humanity through technology. It's really good to be here, Chris and Bob, and thank you everybody for attending the webinar. We have a particularly large audience today, so obviously we are discussing a subject matter that is near and dear to many practitioners. So thank you all for being here.
Great, well, thank you. So let's start with a few questions here. I talked a little bit earlier about the fact that COVID-19, some supply chains are broken. It's really exposed some of the gaps in supply chains. As you guys look at what we've experienced, the last 4 to 6 weeks, what are the biggest flaws the COVID-19 pandemic has exposed in company supply chains?
Avi, you wanna go first?
Yeah, sure. Bob, I think that first and foremost, we realize how heavily reliant we are on very complex supply chains that go all the way back to very distant, call it low-cost producing countries that over several decades master cost and supply chain reliability, but added so much complexity that when it shuts down, it basically shuts down plants across the world. And we learned that recovery is not easy. The second thing that we learned is that in certain parts of industry and healthcare, we were just not prepared adequately because we come into it through decades of refining and optimizing supply chain, where we make it so much just in time that there isn't a sufficient stockpile to mitigate periods like this of supply scarcity. And certainly in certain areas that we don't have today's responsive tools and technology to either de-densify factories when we need to distance, or to quickly spring into action with onshoring and nearshoring alternatives, because the tools are someplace in China or Vietnam.
Chris, I know that Henkel works across industry verticals. You specialize in automotive. Talking to your customers or potential customers, what have you seen?
Well, I think Avi got it right. I mean, it's the ability to react quickly to changing environments. I mean, this is obviously a very special, special is probably not the right word, but it's a very unique situation we found ourselves in. I don't think anyone could have predicted, when we were just after Christmas, what was going to happen in March. And so it clearly shows that, supply chains can easily be disruptive the way they're set up right now. And there's no harm and no foul in that. This is a very unusual time. But out of that, I think as we go through this conversation, we'll see that, 3D printing, additive manufacturing, as I like to call it, more than 3D printing, it is something that can help and is quite exciting. And the question is, after the crisis, how do we take advantage of the learnings and how do we make it a part of the infrastructure and the supply chain going forward?
Thank you. One of the things that folks have talked about a lot, particularly after the tsunamis and the earthquake in Japan that took out the nuclear reactors, and a lot of supply chains went down then, was risk management. But risk management is only half the equation, right? You can prepare for certain risks, but as the bumper sticker says, stuff still happens. And the second part of that is resilience. How do I come back? And a lot of what we're talking about now in terms of the supply chain is, well, how do I come back? How do I develop a resilient supply chain? How do I become agile to respond to things? So, as we've learned, we've seen things go down from COVID-19. What have we learned about agility and resiliency, and how do we think about overcoming future shocks to the supply chain?
Yeah, but Bob, I think that we're learning a lot of powerful lessons. One lesson is the importance of upfront design and design agility, and what can happen when you literally can activate or crowdsource designs and manufacturing devices around the world. It was very powerful to see, for instance, how quickly thousands of practitioners in additive manufacturing were able to open source and share designs and begin to supply particularly fundamental mission critical supplies like PEP and ventilator valves, and now nasal swabs for testing. It's very powerful. It also begins to expose some cracks in the regulatory system that's unable to respond. So we'll need to learn more about how to implement greater design agility. What's the role of crowdsourcing innovations and how powerful it is? How does it impact on IP? And also, how does the regulatory system becomes more resilient in the process? The other part of it is to see how can we begin to apply technology to introduce greater resiliency. And certainly 3D printing additive manufacturing, by virtue of eliminating tools and compressing lead times and providing greater response time, in combination with tried and proven automotive and aerospace processes like PPAP that I'm hoping that Chris will talk about some more, in combination with other technologies for better planning like machine learning and greater reliance on data analytics, will bring greater predictability and resiliency to the other side of it, powered by robotics and 3D printing.
Avi, before we go to Chris, can I bring you back to something you mentioned, which was, sharing digital design, sort of crowdsourcing designs, but the regulatory piece not responding. Is it the fact that when we're now working digitally, we can work faster, and regulatory is still, to use digital analog, regulatory is still sort of an analog process? Is it that regulatory systems are not able to react as quickly as the digital, design and crowdsourcing and sharing processes? Is that the issue?
Yeah, Bob, I think that this is certainly a big part of it, in the sense that when you work around the world and you digitally collaborate in real time with colleagues all over the world, the sun kind of never sets on the co-creation process, right? You work in different time zones, and you can literally teleport parts, because if I have a printer and Chris have a printer, we can iterate and hold the same part in our hands, literally, concurrently at the same time. And regulatory systems don't work quite that well. But there is another, I think, deeper muscle here that we are uncovering in this era. And that is that the DNA of regulatory agencies is to slow you down and check you and verify you. Agility is not in their DNA, and they're largely focusing on approving devices and machines, whereas in a digital thread kind of a process, you really need to approve the process itself, which is why it's so important as we go forward to work together, companies like Henkel and Nexa and others, to establish the approved and robust workflows and processes, because those could scale much faster in times like this.
See, that Bob, is really the criticality of the whole thing, right? In a crisis, obviously some of the rules get dropped because there's a need for nasal swabs, right? So, additive, there's lots of strings in what have you said. I mean, additive is a very fast way of validating designs, obviously. So that's something that we can learn from the crisis, that you can actually get to production very, very fast. But in a crisis, I don't want to say that the regulatory team I don't want to say they're slow, deliberately slow. They're not. They're trying to protect the public, and the history is such that they know that that's a needed thing, right? But it is important that we learn from an additive perspective what needs to be in place so that we can be agile when inevitably the next crisis comes. It doesn't have to be a COVID crisis. It can be a tornado that hits a plant. It can be a tsunami. It can be anything. And so the key for the additive industry post-crisis is to put in the workflows in place to make sure that we can be agile and people trust that the technology can give you a reliable solution. Then I think we can be unbeatable at a certain level, right? So that starts with the material. It starts with the material that is validated, that we know how it works, and then it goes to a printer, to a process, to a design, and this is out of order probably because the design comes early, and then everyone has confidence that they can get the same thing every time. And then if you transfer that process to multiple people in an organized way, then hopefully, or by planning, you can get a reliable solution. So that's the key going forward. And, we all know that additive has been around for many years. It's been around in prototypes for many years. Now we've got to take that huge jump into production and prove to our customers and to the regulatory agents that we have a reliable workflow, starting with the material and design, all the way through producing the part. I'm sorry I've been in automotive for so long, but I think there's a lot of learnings. Of course, automotive is a conservative industry. But in the end, I mean, no one in this room, or no one listening wants to buy a car, slam the door the first time the door falls off. So there is a reason for these processes to be in place. And we've got to take, we have to be respectful of those, respect those processes, and then try to build what additive can do to make them better. That's the challenge for the future, and I think we can do it. And I think we've shown in the crisis as an industry that there's great possibilities.
One last sort of big picture question in terms of where we are in the supply chain. So, you know, we're all talking about recovery. We're all talking about businesses coming back. How do companies approach recovery and continuity plans over the next 6 to 12 months? And I think more importantly, how are they going to rethink and redesign their supply chains? Chris, Avi, which one wants to start?
Go ahead, Chris.
It's a great question. I mean, I don't think it's 6 to 12 months. Obviously, everyone wants to get started, I think, as soon as possible. And they are. I mean, they're starting, and obviously supply chain is super critical because I hate to keep coming back to automotive, but there's lots of different pieces. And if the supply chain's missing a washer, well, we're not building a car, right? Because it's part of the bill of material. So it is critical right now to get the supply chain up and running and as fast as possible. Avi already mentioned there are tools in different countries, different locations, all of running under different rules right now. Even different states in the US are running under different rules, right? So it's a tremendously complex situation. So Additive can help because, you know, we can source parts, let's say, potentially going forward in any state or in any country, but it has to be controlled, obviously. So yeah, it's a challenge, and we have to work on it as an industry, and I think we're heading in the right direction, but we have some ways to go, but I'm very encouraged, very encouraged.
Yeah.
One of the things that,
if I can add,
oh, I'm sorry, go ahead, Avi.
Sorry,
Yeah.
I think that the good news is that there is quite a bit of precedence and traction here. You know, for example, if one looks at the role of additive, say in dentistry or in orthodontry, there we have seen significant process standard adoptions and scale that takes it to the tens of millions of parts produced, you know, per annum, with really shining examples of companies that have built their entire digital manufacturing supply chain on the back of it. Companies like Invisalign, for example. If you look at aerospace, you can see almost a 2-decade example of employing 3D printing and additive manufacturing in production, you know, first of some military aircraft like the F-18, and more recently on some commercial jets, you know, including engine parts. So there is a great deal of traction. The attraction and attraction. The attraction is that you can really simplify and localize your sources of supply. And you have even greater opportunities to reduce the part count by combining, you know, multiple parts into a homogeneous unified assembly that can be printed, because with 3D printing, you kind of have complexity for free. You don't have to rely on tools that can be all over the world and subject to different constraints. And your cash velocity, or your ability to recover your cost of tooling and your ability to continue to customize and localize increases a great deal. So there are significant opportunities here to simplify and localize, to reduce number of SKUs in a complex supply chain, to reduce the labor that is associated with it, and then to put it together with other exponential technologies, because it's not just 3D printing standing on its own. It's in combination with robotics. It's in combination with AI. It's in combination with the right PPAP type processes that are well understood and robust. It's in combination with chemistry that can unlock new capabilities, the likes of work that Chris and Henkel are doing right now. When you put it all together, you have a very compelling value proposition that I think COVID will only accelerate the adoption of.
I'd like to ask you a question, something a little bit that we didn't talk about the other day, but I think is appropriate to actually, Avi, to what you just talked about. And I'll throw this out to both of you. We think of 3D printing as a new technology when it's been around, you know, for 20 or 30 years. And we've kind of moved from, hobbyist and prototyping to, say, parts with little demand where, I only need a few of them a year, but my minimum order quantity is 1,000, so why not 3D print them? And now becoming where it's economically viable in some parts, where it almost approaches injection molding in some things. As both you and Chris look at the landscape, where are we today in terms of, applications for 3D printing, and how is it moving towards, becoming economic viable for mass-produced parts? What's the landscape today to both of you?
I mean, frankly, it's another tool in the toolbox, right? So we have to look at it like that. I mean, I think it's a mistake to say, throw away all your injection molding machines. That would be a little bit of a mistake right now, I think. But clearly the inflection point when parts can be made by additive is increasing day by day. And it will continue to increase as technology improves, automation improves. And so we have to join the journey. I mean, clearly additive or 3D printing has been around for maybe 20, 30 years. And as you pointed out, it's been in prototyping. It's had different technologies and people have got their impressions of those technologies. We have to change thought processes and move ahead by being a reliable partner and continually showing that to industry in general. And as I say, it's all about APQP, final PPAP, and delivering a quality part time after time. No one really doubts injection molding because it's been around for, I don't know how many years, 50 years, 60 years more. And we have a challenge. Yes, we have a challenge to show and continue to show reliability. And I think we are doing, and we will continue to do so by following the process and giving a reliable product in the end. That's the key. That's the key, a workflow to being successful, in my opinion. Because, it's like anything, 99 good deeds are undone by one bad deed, right? I mean, that's human nature. So we have to be really diligent going forward, learn from the COVID situation, take advantage of what we've shown, but be really, really diligent in how we go forward.
Avi, do you want to take a swing at that?
Sure, I agree with everything that you said, Chris, particularly about the fact that one does not magically displaces the other. What we're going to see here is more hybridization of processes and more digitization. For example, 3D printing is already being used very effectively in some tooling and tooling inserts for injection molding. 3D printing is increasingly being used as the digital input to investment casting, because it combines, the flexibility of a lost pattern in a casting application with a cost-effective traditional method, and it kind of turbocharges it. In many instances, as we go forward now, we're going to see massive disruption, for example, in mobility, which means the need to move faster on many different models, manned and unmanned, ICE and EV. And if you just take automotive in and of itself, the landscape post-COVID becomes so much more challenging and complicated in terms of the number of models and the ownership models that will come with it, and the ability to respond to certain markets, that 3D printing, by nature of its flexibility, resiliency, and compressed time to market, provided that we have the required PPAP, in place to do it effectively, repeatedly, and at scale, meeting all of the performance and safety requirements, becomes really a weapon in the chest of especially the innovative companies that are going to chase these opportunities. The same can be said for the drone industry. The same can be said for first mile, last mile, robotic devices. And so I'm very excited, optimistic, and also very sober about the enormous responsibility that is being placed on our shoulders to do it well and to do it in collaboration with industry members, because the only thing that we're not going to have is a lot of time to do it well. COVID created, I think, a significant accelerant in the need of companies to seriously re-examine and completely transform how they think and how they architect supply chains going forward. And it's more likely than not that we will have subsequent COVID-like events, which will further exacerbate an extended and a fragile supply chain. And it's also possible that the way that we look at cost in a supply chain will forever be altered in terms of how we value and evaluate the cost per part when parts are not available for extended periods.
We're getting a number of questions actually from attendees. So I'd like to remind attendees, use the little Q&A function at the bottom of your screen. I want to ask Avi and Chris one more question, and then I'll go to some of the Q&As. And Chris, it's something that I think you hit on a little earlier in your last answer, which is, what are additive manufacturing companies going to need to do to convince industry that they can support a more dynamic and robust supply chain?
I think we've touched on that a couple of times, which is basically a reliable end-to-end solution, right? Starting with the material and a reliable material, reliable printers, knowing how the printer works, knowing the failure modes of the printer, predicting the failure modes, design, as Avi pointed out. I mean, if you can, I mean, design rules are, I wouldn't say off. I hate saying design rules are off for additive because they're really not, but there's a lot more degrees of freedom with additive than there is with traditional manufacturing techniques. So finding those applications that make sense and then delivering them reliably. And that in the end is what every industrial, medical, every customer wants, because they have to sell a reliable product at the end. And you're part of the supply chain that if you break, they can't sell. I mean, I think there's tremendous growth opportunities. There's a tremendous amount of push for things like, I mean, electric vehicles coming, which won't initially be 1 million trucks a year. There'll be few. There's a great push for customized vehicles. This again is smaller volume customization type things. There's lots of great opportunities for additive in the future for applications and to also improve the supply chain. I mean, I'm not sure. I mean, some of the supply chain people on it are probably going to kill me, but sometimes supply chain purchasing people don't think about the disaster and what happens. But you know, if you don't have parts because your supply chain is broken, you're losing a lot of money. And the decentralized nature of additive could definitely help, but we have to put, you know, certain regulations in place to allow us to take advantage of that and allow the supply chain to take advantage of that, right? So it's an exciting journey. I think we're at this, you know, I wouldn't say we're at the start, but we're not near the end. Let's put it like that. So there's a long way to go. And I am encouraged that we can do it. We've proven, I think, in the COVID era that that there's industry can react quickly, design quickly, implement quickly. And I think there's enormous value in that, even in non-crisis times. And it's just a matter of, you know, working hard, diligently, putting the processes in place to make that happen. I'm a big believer that a house is built with a foundation. So you need to build that foundation or the house falls down, right? So we don't want the house to fall down. So we need to build the foundation, which is workflow, reliable materials, reliable printers, APQP, off you go, right? Part number one is the same as part 1 million. That's what it should be, right?
Avi, do you want to respond to that?
Sure. I will echo what Chris said about the industry coming together and showing very quickly the power of design agility, the power of putting resiliency, you know, where gaps formed or cracks formed. I think that we also learned out of this, Chris, that no one company can do all of this alone. We learned the power of collaborations and convening the right partners to really not only tap into the collective wisdom, but to tap into the collective capabilities. And I think it takes that kind of collaboration in post-COVID times to institutionalize it and scale it so that, you know, part 1 and part 1 million all look the same and people can print with confidence. I also think that there is a great opportunity here for the non-techies in supply chain, you know, the consultants and the architects of supply chain should also come into the fold and ask themselves, you know, what are the key areas that will change supply chain and manufacturing? And as I see the opportunities here, I see an opportunity to completely rethink design agility, because every supply chain starts at the design change. Make no mistake about it. You know, that's when costs are committed. That's when sources of production are decided, and so on. So design agility and design thinking and design rules go into it. And then how do you set up your supply chain in a way that it has more resiliency and maybe it's more distributed and mitigated? The third is, how do you set up the factory of the future? Because we're gonna go back now into different rules, different requirements. How do you begin to set the proper de-densifying of factories? What's the role of 3D printing in it? What's the role of collaborative robotics? What's the role of humans? And how do you do it in a way that if, God forbid, we have to self-shelter again for a few months, supply chains can continue to run by remote control or semi-autonomously going forward? All of those elements are part, I think, of the opportunity to create and make a better future in a post-COVID era.
Thank you. So let's go to the to some of the attendee questions. So the first one here, throw it out to either one of you. How do you see the potential for scaling up additive manufacturing in different regions of the world?
I mean, I don't see any real difference in terms of which region. I think actually one of the strengths of additive is that you can literally print in any region of the world. You don't need a tool, you don't need to move a tool, and so you can print in any region of the world, I would think. Maybe I'm misinterpreting the question, but yeah, it's applicable everywhere. There are different cost inputs in different regions of the world, obviously, but and obviously their supply chain has been set up to take advantage of that. I think we all know that, and certainly, you know, the vision of additive in the future is that a lot of those costs will not be valid anymore, so that you could bring back, you know, production into more high-cost labor countries, let's say, without the penalty that you might have with more traditional methods. So I think it's hugely flexible to do whatever you really would want with it. Certainly, I think most industries would like to have their parts produced closer to where they use them, and that's a big advantage that I think additive can help with.
Avi, I'd like to throw the next question your way, given that you have two roles, one as Nexa, but also as a venture capitalist. So I'm going to paraphrase this question because it's a little bit long, but basically what the questioner is saying is, in a post-COVID world, it's kind of a given that customer spending is going to fall. So revenues are potentially going to fall. That might be a barrier to capital investment. So how do you convince companies in a capital constrained environment to adopt 3D printing, in other words, to make those investments?
Well, I think that it's an excellent question because, as you know, in an environment like this, the first area is to suffer is capex, and companies, you know, hit the brakes very quickly, and then they reassess. I also think, and from my experience in managing companies during previous crises like the 08, 09 recession and the 9/11 interruption, is that typically these are the most strategic times to invest in the next phase of your business. And I think that the universal takeaway for any business here and now today, as we're coming out of COVID, hopefully, is that almost every business is going to have to reinvent itself in some fashion. And you don't have to look very far to ask, you know, how will hotels or airlines or automotive will reinvent itself? How will aerospace reinvent itself if there isn't demand for so many airplanes in the next few years and so forth? Supply chain is at the heart of it, and investing in the right tools and showing that you have the vision and the ability to execute for a better next chapter makes your company more investable. And so, you know, if I look at this as an investor in publicly traded companies or in venture companies, I'll have my own checklist now, and I'm going to ask myself, you know, how well is company X preparing itself for the next phase? And I'm going to make my investment decisions based on that. So at the end, Bob, it all boils down to how will companies allocate their precious cash and human resources next month and in 3 months and in 6 months, because that will tell me as an investor if I should make a bet on them. And I think that companies that will fail to realize it, to allocate the right resource and to pivot will be presiding, you know, over their slow demise, except they may not yet know it because they're hanging on to yesterday's cash instead of making the right calls for tomorrow's business model.
Thank you. This question is for both of you, for Chris and Avi. How are Henkel and Nexa3D positioning themselves in regards to 3D metal printing?
Well, I think from a Henkel perspective, I mean, our strength has always been in the organic side of things, let's say. So I think it's fair to say that we took a look at metal printing and whether it was of interest to us, but it's not strategically something that we're interested in the short term. Who knows in the future, but right now, not in the short term.
Yeah,
So that's the Henkel. Yeah, Avi, go ahead. I'm sorry.
I'll complement what Chris said, because we also recently entered into a partnership with Henkel to actually expand the use of photopolymeric resins and to unlock better performances and capabilities that fit more into lightweighting and sustainable solutions that can begin to mimic some of traditional injection molding in plastics and other applications. The connection to metal here could come for both companies from castable materials and getting, you know, casting into foundries potentially. There could be an interesting connection, but at the moment, neither Nexa nor Henkel are actively pursuing direct metal printing.
How about hybrid? You know, I visited the University of Louisville's 3D printing lab a couple of years ago, and one of the things they were working on was hybrid that, you know, mixed materials. It was some metal, mixed metals, but also metal and other non-metal materials. Where is that in development?
Are you allowed to ask questions, Bob, or is that allowed? I really don't have a comment on that. I don't pretend to understand that technology. So Avi, it's you, I'm afraid.
We're in the challenge round now, and Bob is challenging us. Yeah, the answer, Bob, is that there is some work on hybrid materials, and there has been a great deal of work over the last few years, including in the photopolymer, curable photopolymer resins with ceramics. And that is an interesting thread. And there are, of course, all the work around composites, which potentially could create stronger and lighter materials. Because remember that at the end of the day, our interest is also to create solutions that are much more sustainable, that deliver, better performance. I mean, if you want to go back to automotive, lighter parts, fewer parts that consume less energy, that extend the range of a vehicle. In aerospace, fewer, oil burning points, in a certain range. That's where we're concentrating today. And in terms of metal replacements, there could be some interesting materials down the path that could begin to get closer to structural integrity and performance, but lighter weight. We're not there yet.
Yeah, maybe fillers is an area that hasn't been a strong point in additive right now. In order to suspend a filler in solution, there may be some things there, but that would increase engineering properties, let's say. I mean, most polymers are injection molded in a glass filled or somehow filled. It's tough in additive, but that's an area that potentially going forward could happen.
These next two may be the challenge round, but in deference to Chris, these are from attendees, not from me. So,
oh, good.
We have a question here that I think is a good one. So key to taking advantage of additive is design for additive versus can you print what I already get injection molded? Do you guys see this as a hurdle for adoption?
Well, I mean, one part of APQP process is design for manufacture, right? I mean, so it's really a limited interest. Let's say, I mean, it's going to happen, but it's a limited interest to try to 3D print parts that were designed for injection molding. So it's super critical to optimize designs and work with designers to optimize for additive, right? But it's a different process. It's just like saying, oh, can you make this injection molded part blow molded? It isn't probably going to work. So we have to, that's key. That's really key. Design for additive will sustain us for the future. Avi already talked about how you can, combine multiple parts into one part you couldn't do any other way. That's another way of designing for additives you can't do in injection molding, blow molding, or any other traditional way. Channels, interior channels in parts are very difficult to produce by traditional way. I mean, those sort of things are going to drive the value opportunities for additive going forward. And if we just sat here and said, we'll produce injection molding parts, but we'll do it with additive, I don't think we'd win very much, but we win some, but I think it's key, absolutely key.
Yeah, I couldn't agree more with Chris that if it's already designed for injection molding and it's working well, there is no advantage to try and replace it. Some people do with limited success. Where I do see a big push to take parts that were designed for injection molding and print them is in aftermarket spares, because increasingly what we see, for example, at Nexa3D and at Exponential Works is we see automotive companies coming to us and saying, listen, we're required to keep this spare. It's a low moving part. We can't even have room to store the tools anymore, and we can't find anybody that would free up a machine to make a run, and it's not economical to make those runs anymore. Can you please begin to help us gear up? And there are literally tens of thousands of parts that fall into that category. There I see almost a groundswell, because we're getting to a point of model proliferation in which just the legal obligations to be able to supply a spare part for X number of years, after the model runs out, requires warehouses that are filled with these aged tools that see very little action and no takers to put them back on presses to inject the parts.
Yeah. as an injection molded, as background in injection molded, we're actually obligated to do that. But and so I definitely would agree. I definitely see that as a strong area of growth potential for additive. But here's how to make it really the area of growth. When we're working with, let's say, automotive up front, that we parallel path a design process and a validation process up front with an additively produced spare part. That's how it makes it happen, because in reality, automotive companies want the spare part to work the same way and perform the same way as the original part. And I think there's some give and take on that right now. People are pragmatic enough. Tools are lost, tools are broken, you know. But I think the future is working up front with them. Again, it's on design, not necessarily design, but validation of an additive spare part solution that then is interchangeable. That's how that becomes a sustainable business, I think, in the future. And yeah, I think it will happen. And there'll be opportunities because of lost parts and just the low volume of trying to keep up. And we've definitely seen that, but that's the sustainable solution is co-design it as an additive part. If you want it injection molded, make your aftermarket parts additively produced. And that would take a whole bunch of stress off injection molders, I'm sure.
Chris, this next, given your automotive background, this next question it might be a good place to start with you. Questioner or attendee asks, what are the key changes that are required to shorten the implementation time for vehicle OEMs and service providers? What could be compressed in the process, starting with ideation, part identification, material choice, test, and evaluation of the printed part?
I think, as I say, I'm a big believer in building the foundation, and then you can springboard off that foundation. I mean, clearly, a big advantage of additive is that you can really quickly have design iterations that maybe in the past has required even a soft tool that might take 2 to 4 weeks, and then you have a design change in the design process that then takes that tool out for another week to get it adjusted. I think that additive can definitely compress the design process up front and then the validation process. I mean, pretty much, you know, I mean, there was always a dream in the past that you could simulate how a vehicle would work and never have a prototype part. It hasn't really come to fruition because you still have prototype parts, and there's good reasons for that. And so the whole process of design to production can be shortened by additive, in my opinion, hugely, right? So it's there, and then quickly, you know, it's strange in automotive. You never think you design a car, you never change it, but there's always design changes. Then you have a tool in your press. You have to build a inventory of parts to keep you when you in production or in supply when you pull the tool. And then, you know, there's always risk there that it doesn't go back in right, or it doesn't produce good parts. So there's, you know, from a supply chain standpoint, I don't think we really capture that in the cost of, you know, design changes before and after the fact. And I think if we delve into that and find companies that really want to look at that, I think they'll be surprised how much additive can save them and narrow the gap between additive and traditional methods. So I do think, you know, it's in design change, you know, and then the speed of that. I mean, believe me, there's nothing worse as a plant manager having your tool out, having your bank being depleted, and there suddenly something's gone wrong with your tool. Now you're, you know, in the tool shop, right? So, you know, that is, the stress alone would be worth it, supply chain professionals, I can tell you that. But I mean, it's all those design changes I think that additive can really help the process.
We're coming up on the 50-minute mark. Do you guys want to go one more question?
Sure. The bars haven't opened in Michigan yet, and I know in California they
have. New Hampshire, it's always 5 o'clock somewhere.
Yeah.
Do you see the AM COVID-19 response as an opportunity to prove the credibility and reliability of 3D printing as a manufacturing process, or as a way to see the requirements to then prove AM as a reliable manufacturing process? Either one of you.
Well, I think that the industry already has proven itself dozens of times, you know, since the beginning of COVID-19. in terms of its response, its inventiveness, its design agility, but also the opportunity to step up and scale certain processes literally within days and weeks, including credit to the FDA and NIH, and VA that also stepped up to and brought their own 3D printing experts to the table to help with fast tracking certain tests and approvals. So we're building, I think, here on a very robust capability of the industry that certainly has been validated overnight. I think that the question now is, what do we do with it in a post-COVID, and how do we begin to build the very scalable infrastructure that Chris was talking about, for the benefit of SMEs and large businesses, and as part of reimagining and quickly transforming supply chain in a way that sustains, scales, and gives us the resiliency. As a separate part of it, we also need to ask ourselves, what do we do about the next potential pandemic? And should we, for example, have in our emergency preparedness stockpiles lots of 3D printers so that we don't run out of face shields and ventilator valves and things like that in the future? How do we, should 3D printers now become part of a country's national preparedness and response stockpile of capabilities, instead of storing all these tens of thousands of very slow or never moving parts unless you have an emergency? Those are questions that we need to ask ourselves as well. And I think also, as part of all of this, we learned a great deal about the future of work, because at the end of the day, in many instances, we learned that 3D printing, or I should say generative design and additive manufacturing in combination with Zoom can become a very powerful way of working remotely and delivering the ultimate distributed manufacturing. Because we've seen all these home printers, these little plastic extruders, ranging in price from $200 to maybe a few $1,000s, sitting at home with high school students and hackers and makers. And for the first time since all these printers became so ubiquitous, in the last 6-7 years, we saw printers all over the world making something really, really useful almost overnight, in a way that gives you a window into hyper-local distributed manufacturing. I'm not suggesting that the future of supply chain is going to be on every middle schooler's desktop, in their den, or in every maker's garage, but I am suggesting that it begins to shape and inform a new way of working that is much more hyper local, distributed, nimble, flexible, and by definition more resilient. And the key is going to be, for how do we as companies and organizations take these lessons and implement them into our supply chain strategy?
Yeah, so it's hugely illustrative, isn't it? I think the answer to the question is both. That's the simple answer. Swabs have been developed, designed, brought into production in, I would suspect, record time. And it's a combination of, additive companies working together, the regulatory agencies being a little more compliant, let's say. But the key has been to quickly design something, quickly get something to production in a crisis, right? So it's hugely illustrative. It's great kudos to a lot of people in doing that. The question is, when there isn't a crisis, how can we take advantage of that, right? That's the real question going forward. And I still come back to the fact that you need to develop and you need to build trust in workflows and materials and designs. And that is the future going forward. But we have a tremendous opportunity as an industry now, you know, to take advantage of what we've done, and great teamwork, and move it into the future. Will it go everywhere? No, but I think it's a driver going forward to put it in place, the processes needed to make this a bigger and bigger business. Seriously, I believe that. And it's with us, really. It's with the people in Additive to make that happen. I mean, you know, and there will be companies out there that won't. I mean, customers out there that won't want to enter, but I think it's a wake-up call a little bit for companies that, you know, now to take Additive a little more seriously, perhaps, and build that foundation under it so that we can take advantage of it. I really don't want to be in an industry where, you know, we have to wait for the next crisis. We don't want to be in that industry, right? We don't want another crisis. Inevitably, it will happen. We want to take advantage of the learnings from this crisis to further propel Additive into the mainframe, right? Into the mainstream of manufacturing where it makes sense.
Two last questions, and they're kind of related. So the first one is, with the focus shifting towards 3D printing, how do you look at the demand for or importance of 3D printing education in the coming time? So I'm guessing that's what's the role of, you know, universities, academics, and education?
Absolutely critical. Absolutely critical. I mean, and I'll give you an example. I mean, Henkel has been in structural adhesives for automotive for the longest time, and traditionally it was welded, right? And the universities probably taught welding, flange design for welding. So it's super, and so that, it to an extent delayed the introduction of structural adhesive. And you could argue the same for additive 3D printing. We need to train the engineers for the future of what the new toolbox is going to be. Or we will have designs for injection molding, for stamping. We will have designs for additive. So super, super critical. And I'm encouraged because I think, you know, I'm obviously a young guy like Avi, right? But I think the young people find additive really exciting because, you know, the immediacy, honestly. So I think there's a pent up excitement to be part of additive. And I think it starts at the universities where we need to train the engineers of the future to design for additive.
Avi?
Yeah, I mean, I think that it's almost you know, this kind of what I call digital literacy is almost becoming kind of a human right. I'm encouraged to see that even middle schools and high schools now have 3D printing labs. I'm encouraged to see that many libraries, public libraries, as they search to, you know, kind of find a new meaning, you know, in a digital world, you know, have maker spaces that include 3D printers in those universities. And I'm really excited about all the work that my good friend Dean Kamen has been doing for decades with First Robotics, you know, which now has closing in on, I think, almost 40,000 First Robotics clubs around the world, and what young kids and high schoolers are doing in terms of pushing, you know, robotics technology using design tools and 3D printing and electronics to create amazing things. And I think that in a post-COVID era, we need to remember that we also created the largest unemployment in recent recorded history, certainly since World War II, at least on a temporary basis, one hopes. And so as we contemplate about how we put everybody back to work in a productive and impactful way, there is also a role, I think, for some additive manufacturing literacy training for young adults like Chris and I, who kind of missed out on high school and university. You know, maybe we can get opportunities for some local training as well. And I think that it's an opportunity for communities and government maybe to partner and think through how 3D printing can be part of the future of work.
Dean came in, not my neighbor, but a fellow Granite Stater here in New Hampshire. So one last question, and this is from a recent college graduate. So kind of going back to that education theme we'll wrap up with, which is essentially what he's saying is, how do I find a job? But his question was, how do I search for positions related to additive manufacturing during COVID-19?
I don't know. I mean, to answer the question, I think there is, for a college grad coming out of college with experience in additive manufacturing and a passion for it, I think you'll find a job. Yeah. I think the future is bright. I mean, you might be a little frustrated right now. I mean, obviously the news on unemployment's not great. Probably not the best time to come out of university. But for someone with additive manufacturing background and a passion for it, you'll find a job. If you have a passion, you'll find a job. I mean, I could tell you, call me a Henkel, and we'll see. But
I was going to say, Avi, are you hiring?
We actually are hiring, and if you go to the Nexa3D website, you'll see all the jobs that are open, and I am happy to say that we actually figured out how to onboard new teammates remotely, which is another challenge of the times. But in all seriousness, there are lots of active forums online for 3D printing practitioners. There are lots of user groups on LinkedIn, so it shouldn't be that difficult to plug in and become part of the community.
Well, thank you. I think that's all the time we have. We had a great showing today, but I also see people certain log off and go back to work. So thank you for attending. I'm Bob Treblecock from Supply Chain Management Review. I want to thank Avi and Chris for a great discussion. And again, thank you for attending.
Thank you.
Yeah. And stay healthy, everybody.
Sure. Stay healthy.
And keep in touch. Yeah.